Okay, good evening, students. Hope you are doing okay. Okay, I welcome you to page sector tutorial. In page sector tutorial, you are sure to have value for your money. Okay, so here I'm going to be dividing the chemistry section or class into three. Actually, chemistry is divided into different sections, but I'm dividing into three, into just three. I'm dividing the chemistry class into three. We have the physical chemistry, we have the inorganic chemistry, and then we have the organic chemistry. And I'm going to be focusing on the inorganic chemistry. This evening, I'll be focusing on inorganic chemistry. And the first topic I shall consider is the periodic table. The periodic table. So that's what I'm going to focus on, the periodic table. Now, we know that the periodic table is a table that showcase various elements, over 100 elements, and these elements are found in different groups and different periods respectively. Of course, we know that there are 8 groups in the periodic table and then 7 periods. Okay, we have 8 groups and 7 periods, we know that. And talking about the classification of the periodic table, the classification of the periodic table. Now, are the elements classified? The classification of the elements in the periodic table. We have the group 1 element, okay? The group 1 element, they also have a name, they are called the alkali. Okay, then we also have the group 2 element. Of course, the group 2 are the one we call the alkaline earth metal. This is a difference. This is alkaline earth metal. The first one is actually alkali. Okay? So why this is called alkaline earth metal? Let me erase this part of the board. Okay, so you have alkaline earth metal. Yes. Now, we have group 3, and that's where you have the boron family. The boron family, that's the boron family, or you could say that as aluminum family. And that takes us, of course, to the group 4 elements. The group 4 elements. Now, looking at the group 4 elements, so we have, let me wipe the board, please. Okay, so the group 4 elements. Now, for the group 4 elements, that's where you have the carbon family. You have various elements there. And then you come to the group 5 elements, you have the nitrogen family. Then you come to group 6, you have the oxygen family. And then you come to group 7, that's the halogens. Halogens simply mean the salt former, the halogens. Okay, that's where you find chlorine, bromine, iodine, and the rest of them. And then you find the group 8 now, and that's the noble gas, the one that are inert gas, like your neon, like your helium, like your xenon, and the rest of them. Okay, so please take note of that. Now, periodic law actually refers to the properties of the element. It is said that the properties of the element are the periodic function of the atomic number. It says that the properties of the element, the properties of the element are the periodic function, the properties of the element are the periodic function of the atomic number. Now, according to the chemist who spent quality time in the construction of the periodic table, Dimitri Mendeleev did an amazing job, an amazing work. But we also observe that, according to him, that the elements in the periodic table are arranged in order of atomic weight, according to Dimitri Mendeleev, that the elements are arranged in order of atomic weight. But further study reveal by further study reveal from Henry Moseley that the modern periodic table is arranged in order of atomic number and not atomic weight, as earlier postulated by Dmitry Mendeleev. Please, I think that is very important for us to note. Okay, that's very important for us to note. So let me wipe this part of the board, which is the periodic law. Periodic law. Now it says that the properties of the elements are the periodic function of the atomic number. What can you deduce from there? Now that means if you have group 1 element, for example, the group 1 element or the behavior of the various group in the periodic table will be due to the behavior of elements in various groups will be to the group in which they are found. Okay, so you cannot compare the behavior of the group 1 element with that of 2, even though they are both element metals, but they will exhibit some kind of behavior that might not be exactly alike. Group 3, group 4, group 5, as a case may be. Okay, so the next thing is to consider the factors affecting periodic table. Factors affecting periodic table. Now, what are the factors affecting periodic table? Number 1, we have what we call atomic radius. Number 2, we have what we call ionization energy. Number 3, we have what we call electron affinity. Number 4, we have what we call electronegativity. Number 5, we have electropositivity. So these are various factors affecting the periodic table. Okay, for example, if you look at there are others. So now, for example, if you look at the atomic radius, or what you call atomic size, okay, atomic size or atomic radius. The atomic radius is the half distance between the nucleus and the outermost shell, the half distance. So you have something like this. The half distance between the nucleus and the outermost shell. So if this were to be the outermost shell, you can see here, this is the nucleus inside. You can see the distance from here to here. So the half distance between the nucleus and the outermost shell is the atomic radius. And normally, the elements in the periodic table, as you move from your left to your right, atomic radius decreases. And the reason is because as you move from left to right, let's say period 3, for example, where you have sodium. Let me wipe this part of the board up here. Okay, good. So let's say period 3, you're looking at period 3 where you have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. Now you know that period 3 means that sodium is 281, magnesium is 282, 283, and so on. By the time you draw and then you draw the third shell, because they will have 3 shells. The distance between here and here, they will have the same distance like this. But you will observe and agree with me that as you move across the period, the number of protons increases from 1 to 2 to 3 to 4. As the number of protons increases, your nuclear charge, which is the attraction between the nucleus and the outermost shell, the nuclear charge increases. And the increase in the nuclear charge is what brings about the decrease, because the nuclear charge will counterbalance the atomic radius. Okay, so as you move from the periodic table from left to your right, atomic radius decreases, while as you move down the globe, atomic radius increases because of the increase in the number of shells. I am sure that's very clear, because if we take, let's say, the group 1 element, you have lithium, you have sodium, you have potassium. You see that lithium will be 2, sodium will be 3, so the distance is getting increased. And then by the time you go to potassium, the distance is increased the more. Like that. The distance is increased the more. Okay, so this is very important for you to note. What other things should we look at? Ionization energy. Ionization energy. Ionization energy is the energy, the minimum energy required. The minimum energy required to remove an electron from a loosely bound atom to form a gaseous ion. So you're talking about the remover of an electron from a loosely bound atom to form gaseous ion. Simply put, ionization energy is loss of electron. Loss of electron. That's ionization energy. Okay, that's loss of electron. So you could have something like this, for example. You see that this is 281. This is 28. Okay, what's happening here? What is exactly happening here? What would you say is happening here? Okay, now what's the oxidation state of sodium here? 0. What's it here? +1. Okay, so what has happened to sodium is that the oxidation number increases from 0 to 1, and that's what we call oxidation. Increase in oxidation number is oxidation, which is also known as loss of electron. Oxidation is a loss of electron. So this is what we call ionization energy. Ionization energy is that decrease, is that loss of electron. And you know, the first ionization energies, we have second ionization energy and third ionization energy. If you have sodium 281 and you have magnesium 282, you have aluminum 283, you have silicon 284, it's easier to remove electron from here compared to here. It's easier to remove from 2 compared to here. The more the number of proton is increasing, the more difficult it is to remove the electron from the outermost shell. So in the periodic table, what happened to ionization energy? As you move from left to right, okay, the ionization energy increases because of the increase in the nuclear charge. Increase in nuclear charge, NC. Okay, why down the group ionization energy decreases because of the increase in atomic radius. So we can now make a conclusion here and say that ionization energy is directly proportional to nuclear charge but inversely proportional to atomic radius. That is, increase in ionization energy or increase in nuclear charge brings about increase in ionization energy, while increase in atomic radius will bring decrease in ionization energy. That's what it's just saying. Very simple thing. Now, what are the factors that affect ionization energy? What are the factors that affect ionization energy? So the next thing is factors affecting ionization energy. Factors affecting ionization energy. Let me write it quickly on the board. Factors. So what are the factors? One, we have what we call atomic radius. Number two, we have what we call nuclear charge. Number three, we have what we call screening or shielding effect. Screening or shielding effect, okay? Shielding. Number four, we have what we call stability rule. Okay, till I come your way again, I remain Tutor Yomi Omorewa. Okay, so I'm going to stop this here, but obviously, you know that there are a lot to learn under this topic, and each of these things have to be explained how they affect ionization energy. Thank you.